Thanks for sticking around the whole day. And I think I'm under control. Oh. Okay, I think this one's louder, so I can talk more softly. So thanks everybody for sticking around. I'm extremely happy for the for the final talk. Of course, if we're having a program on modern paradigms of generalization, we should hear about actual modern generalization settings from an expert in an applied area. So yeah, and just to make the joke clear for everybody that doesn't know my humor, I mean, I think especially when we were originally planning the boot camp, we had a dream of having a lot of applied talks. So yeah, we're very happy to have Alane Suhr. Alane did her PhD at Cornell, and I should say that I was really excited to invite her specifically because I met Alane about a year ago, and I went to Berkeley and went to her office, and I didn't even know if she would, have time to speak to me. And I think it was like an hour and a half that you explained just like neat generalization trick in linguistics and in NLP to me. It was just one of my actually favorite chats from the last year and a half. So I'm looking forward to another almost hour and a half.
Thank you. Is this working? I think so. Okay. All right, so I wanted to start by prefacing this talk with like what's going on here. So I'm a mostly applied NLP person. I want to talk about what in NLP have we wanted to build, how do we know when we've built it, what kinds of generalization have we been expecting from our systems. And then I'm going to move on and I'm going to not talk about NLP models at all, really. And I'm going to talk about how does this generalization differ from natural language processing, so how people use language, and what does this mean for the language technologies that we build going forward. This talk includes a lot of just loosely connected thoughts, and thank you for inviting me because now I'm starting to organize them, and a list of a bunch of open questions, maybe some that have closed. This talk is in progress and I need to update myself on reading in a huge amount of fields, so a lot of these might be addressed problems in linguistics. And I'm also going to talk a little bit about some of the history of NLP and where we got where we are now. This is necessarily a work in progress. I'm going to explain why at the end, but at the beginning, it's because so much of what we do with language is addressing exceptions and being able to accommodate exceptions, and it's really hard to invent exceptions. So a lot of my inspiration comes from observations of language use and then putting them in a talk like this. So I'm always going to be adding stuff to this, so it's never going to be finished. But if any of this resonates with you, especially in the theory side of things, I'd love to talk to you because I want to think about theory and language. Also, I have this URL to a list of references if you want to follow along or look at that afterwards. And it's also going to be on every slide. Okay, so what do we want to build and how do we know when we've built it? So what are the historically core NLP tasks and evaluations? So one of the biggest questions is, what do words mean? There's this working assumption in NLP until recently that a piece of language is a particular, actually this isn't an assumption, this is language is a composition of some atomic units, but the working assumption is that first we need to understand these atomic units and we need to understand how they're composed, and if we understand those two things then we can get sentence meaning, but we need to study these problems somewhat independently. Our atomic units live in a lexicon or vocabulary or something like this. This is the set of possible words, word types, tokens, etc. What's a nice way for us to store word meanings? Does anyone have a suggestion?
Word embeddings.
Word embeddings? A dictionary? Okay, well, word embeddings didn't exist for the Sumerians, but dictionaries did, which is good. This is part of one of the things people used to work on in earlier days in computational linguistics is building dictionaries. One problem with dictionaries is that they require language understanding in the first place, and they're also static entities. They don't change very quickly, although they do change. Okay, so instead of using dictionaries, how can we represent words? We could say, all right, we have one word and we have a bunch of other words. How are they associated? What is the association weight between these words? We could build structured databases that say, okay, we have some entity or some type, and then we have subtypes. So we have medical professionals, and then different kinds of medical professionals are doctors and dentists and nurses, or maybe we have other relationships between different words. Of course, nowadays we use word embeddings, vector representations, where we train some space of vectors to be analogous to like lexical meaning of word types, using things like skipgram, and you can do fun things with these vectors like vector space algebra. For example, wow, this is kind of hard to read, but the vector that takes you from a country to its capital. Okay, so that's like word semantics, but what about sequences? So words appear in sequences. What are the things we can do with those sequences? So one of the things we can look at is like the parts of speech of different words. So for example, the word nurse here, the nurse is checking his blood pressure. This is a noun. Here, she hid behind the bike to nurse her kittens. This is a verb. So this is an example of lexical ambiguity, and it manifests itself here, partially in the part of speech tag of this word. Another common task in early NLP is named entity recognition, where we want to identify things like names of places and people and things like that. So let's say we have the word central. That's one word. It has, a couple of different meanings. And we have the word park, which also has a number of different meanings. But once we combine them together, now we have some named entity, Central Park. And these tags in the angle brackets indicate where the bounds of this named entity. So this is an example of one of the tagging tasks in NLP. Okay, but beyond these like adjacency relations, we also have more complex compositions of these subparts. So for example, let's say we have the sentence, the horse raced past the barn. We can give it a constituency parse tree like this one, where we start with a sentence and then we have a noun phrase combined with a verb phrase. The verb phrase is made up of other parts, etc. And then we can have a different parse of a very similar sentence. If you want to read this, many of you might have seen this before, but can anyone like parse this, the meaning of this sentence? Yes.
Which was raised past the barn?
Yes. Okay. So this is an example of a garden path sentence. These are fun linguistic like illusions in syntax in English here. We also have other things like the boy saw the man with a telescope. What readings do you get from this? There are multiple possible readings. Okay. One is the boy is using a telescope to look at the man, and you can see that this is the parse tree that represents that interpretation. And another is the boy is looking at a man who has a telescope, and this is the parse tree of that representation. So this parse tree disambiguates the meaning of these two due to its syntactic ambiguity. All right, so we've talked about words and how they're combined together to disambiguate different things. But what about getting meaning out of all of this? So one way of representing meaning is to use some formal representation like lambda calculus, which is an interpretable and executable representation of sentence meaning. And if we have a representation of a sentence in a lambda expression and we have some way of executing it, like on a database, then when we execute it, we get a denotation. And sometimes this is taken to be the meaning of, for example, the sentence, what states border Texas? And this is a really elegant formulation of how we can get from individual words to this executable, like gold standard meaning by using what's called a combinatory categorical grammar that makes use of these different combinatory rules that use the parts of speech in order to build up sentence meaning from individual words and their orders. Okay, so now we have texts and we can do things with them. We can get meaning out of them. But what do we want to do with that meaning? So a lot of the tasks in NLP have been like text. Oh yes.
To a question that I'm just wondering if every function in the lambda calculus corresponds to a verb. Is that what's?
No, not necessarily. So, for example, you can have like an adjective that is a lambda expression.
It's just okay. It's better to think of this just like a church numeral, kind of just some embedding into the naturals.
Yeah, I think so. Yeah. Cool. And not a lot of people actually use lambda calculus anymore to represent sentence meaning. We use vectors now. But I think this is a very nice, a very like elegant formulation of language meaning. Okay. Right. Okay. So text comprehension and classification. So we want to see what the text topic is of a news story. We want to do something like sentiment classification. Typically what we'll do is we'll take the piece of text, we'll turn it into some kind of features like the distributional statistics of its lexicon, the parts of speech. For example, here is a set of words or phrases that correspond to, I think, positive sentiment in different reviews for businesses. And we can train different models on these features. Of course, nowadays we can do text classification very easily with language models, but this is all the sort of pre-LM history stuff. Pre-LLM history stuff. And okay, those are these simple linear rules, but what about the compositionality of language? Like, for example, if you have a movie review with a negation in it, like, the difference between I didn't like this movie or I really liked this movie or whatever. So we want to be able to represent the fact that a negation might flip the polarity of the sentiment. So we could use like deep learning to give rise to these like semantic syntactic compositionalities. Okay, so that's nice, but can we get these models to actually produce language? So the most basic task here is unconditional language modeling. The simplest kinds of models here are these n-gram models, which say, okay, given the words that I've produced so far, what is the next word? Or given the last n words I produced so far, what is the next word? N-gram language models are not an old thing at all, or sorry, not a new thing at all. They were described like in Shannon's information theory paper, just the same n-gram models to some extent, minus a few hacks that we were using still back in like the 90s. And then, of course, we had neural models, which are doing something very similar to predict one word given the context of words. So you have some kind of pooling over the previous words, which are represented as coming from the word embeddings that you might have learned from some other text. Another common generation task is like machine translation. So early works of machine translation would use different lookup rules and phrase tables. And then now, of course, we have neural models. And one of the big revolutions in attention was coming from machine translation, looking at different word alignments from going from one language to another. Another common task in NLP for generation has been summarization. So early summarization would be more extractive. So what are the different keywords that might be in a piece of text? And then moving on to more like abstractive generation sort of from scratch, using like RNN-based models. And then I'm also putting in this category captioning type tasks where we take some data external to language like an image or a video, and we turn it into a human readable caption. So these are all examples of a model being used to produce sequences of text instead of just understanding what's going on in an existing piece of text. One issue that comes with NLG is evaluation. So unlike the classification tasks, we can do anything, we can judge anything for NLG. Like the model could have produced anything at all. So we need our metric to be able to evaluate any arbitrary string. The gold standard here would be something like human evaluation. One issue is that it's still subjective. So if you give two summarizations to a person, or two summaries to a bunch of different people, they're not necessarily going to agree because they might have different preferences, for example. But it's still the human judgment. But we can't scale this up to a huge amount of data. So instead, we use things like reference-based metrics or defined metrics that look at like specific attributes of the text itself. And over the years, there have been a bunch of different metrics like n-gram matching type metrics or neural metrics that look at a reference piece of text. So this is the text that we want to get, and then a produced piece of text and just say, how similar are these things? I'm going to start talking a bit about generalization. So we want this metric to be cognitively plausible, and we want it to align with what humans would judge for a piece of text. And so the generalization here is we want our metric to generalize to arbitrary strings, and we want it to align with what people are judging for these strings to any string. Yes. Yeah.
What do you mean by comment plausible, or just
Oh yeah, I mean, I'm kind of abusing that term a little bit. I guess we want it to reflect whatever human judgment, whatever processes a person was using to judge a piece of text. So
you should cover the process, not just
right, yeah. But we want it to generalize to any some person's judgment of the text, or human-like judgment of the text. Okay. So one thing that's not exactly a task, but it's still something that a lot of people have cared about for a while in NLP is model interpretability. Of course, we have this trade-off between interpretability and model performance. So the example I showed earlier with like these phrases for sentiment classification is a good example of an interpretable model, because you can see for each of these features how much it contributes to the model's prediction of sentiment. But once you get into neural models, you don't really have that ability. So I'm just going to highlight a couple of different approaches, popular efforts to this. So there's these questions of whether attention weights or attention distributions can give us an indication of model behavior, with some evidence showing that it's not a great way of doing interpretability. Some people work on like linear probing, where you take some internal representation of a model and train an additional classifier to predict structures that we think should be represented in the model. For example, you take some BERT embedding and you train a classifier to predict different dependency relations, so syntactic features of a piece of text. Other examples are, can we extract information from the language model, for example, by doing this targeted inference where we're sort of forcing an answer from a question like Dante was born in blank. So these are all just a couple of examples of ways that people are looking at what is learned in a model. And to sort of generalize this, what we want out of a good interpretability tool is a tool that will predict the model's predictions from its internal, or a model that, we want our interpretability tool to predict what the model will predict given some information about the model. Okay, so this was all sort of about NLP tasks and evaluation, and now I want to really focus on generalization. I'm not going to stop for questions because I want to make it to the second half of my talk. Okay, so what kinds of generalization have we been expecting from our systems in NLP so far? So the dominant paradigm for developing NLP systems has been evaluating on IID data. So essentially, does our model work for the distribution that we designed it around? And typically what we'll do is take some data set, randomly split it into training, dev, and test sets, and then we'll release it to the world and say, please only train on the train set, please develop your model on the dev set, and only run on the test set once you're done. Sometimes we also have public leaderboards with private test sets where the data set maintainers are the only ones who have access to that data. So we know relatively reliably that the models are going to potentially, I mean, the hope is that we want to generalize to data that's not in any of this data. And if we do well on the test set, that means that we'll do well in the real world. So how do we get a model that performs well on IID data? Usually by getting more training data in that setting. There are also a lot of examples, especially pre-large data sets, of importing different inductive biases into the design of the models. And I'll show a couple of examples here. On this sort of other side of the spectrum in terms of evaluation is evaluation on case studies. So this is sort of how does our model behave in edge cases that we know about? So for one example, we were looking at this garden path sentence processing before. So there's this question, does our parser parse these sentences like a person would, i.e. is it like an allusion to the model? So is it performing potentially, could we say that it's performing the same kind of sentence processing as a person, or does it actually parse them accurately with no trouble whatsoever? Could our system translate words that it's never seen before, for example, names? Or is this fundamentally impossible given the model architecture, for example, like the tokenization? Okay, so here I'm just going to this is just going to be a smattering of a couple different pieces of generalization before I get to like the big one. So one form of generalization that people have cared about a lot, obviously, is linguistic and human variation. So do our approaches, which were designed primarily around English processing, generalize to other languages? So how well do our architectures and tokenization methods and document processing and text pre-processing generalize? But of course, we have a huge amount of variation among language users. So there's these questions over if we develop some evaluation criteria for a task, is this criteria going to be robustly interpreted by a bunch of different annotators? So is our task well-defined at all? is our task genuinely ambiguous, or is it dependent on external factors that our model could have no access to whatsoever? So like if I ask ChatGPT what my favorite ice cream flavor is, it's like not going to be able to answer because it literally doesn't have access to that information. And I think another question is like, are there tasks where we just genuinely don't have a good definition of generalization because the task is either subjective or like super dependent on the person who is interacting with the system? Okay, so another aspect that has been a big focus of NLP for a while is what about language as it's used in contexts? So for example, most early work in NLP has focused on things like processing words and phrases or sentences, or featurizing longer documents so that they can be easily processed by like log linear models. But text often appears alongside other data like longer documents, multi-turn conversations, or even documents outside of language like images and video. So how do we get our models to work for these things? We use different model architectures. For example, this is an example of importing some inductive bias, in this case, document structure. So this model was designed for documents where you have some sentence representation, and then those are hierarchically combined into a paragraph representation. So now, the hierarchical structure of this model reflects the hierarchical structure of a document that we assume exists. We can also use different architectural efficiencies, so more like systems level innovation, to store more information in the context window. So for example, in Gemini 1.5 Pro, there were significant architecture changes that allowed for, I don't know what they are, but that's what made it happen, according to the technical report, which now supports 10 million tokens in context. How do we evaluate generalization to these very long contexts? One of the ways that we have done this in the last year or two are these like needle in a haystack type evaluations, where you provide the model a huge set of context, tons and tons of tokens, and you place some piece of information somewhere in there. And then at the very end, you want the model to recover that information when prompted for it. And so this diagram is showing when you place this needle at some position in this context window, is the model able to recover it? And in most of the cases, this model is, which is great. But once a model is able to do one thing, can it do another thing? And I think a lot of people now are also talking about, can it do multi-hop reasoning over various pieces of information that are stored in the context? So like if you have two documents at very different places, can you then reason about, for example, the relationship between those two documents if you've never seen them before? So people are constantly creating new expectations for these models. Okay, but another thing, of course, that we can do is just more data. So for this is, I think, an image captioning model, or maybe this is just a general. I think this is just a general vision and language model. I think this is Blip. And so you have the architecture on the left. And one of the issues is a lot of image language models are trained on data that's web scraped. How do you get paired data? Well, you get images, and then you get their alt text. And this is just whatever the website owner decided to like put alongside their image. So it's actually extremely noisy. So one of the challenges that this paper was looking at is how can we denoise our training data? And so one of the things they proposed was filtering and replacing the low quality alt texts with model generated alt texts. And this makes the model perform better. So we also want our models to perform well in new domains and with new modalities. So this is a setting where, for example, our model has little or no data in a target domain, for example, like a medical domain, or if we're trying to generate code instead of text, natural language text. So our output space now looks very different. So there's a lot of different things that people use to make this work. So maybe you have a small amount of labeled data in your target distribution that you can train on. Maybe you have a bunch of unlabeled data in your target distribution that you can fine tune on or even pre-train on. You can use synthetic data to improve or to augment your training data set, like we just saw with those image captions. And then another example is you can also import these inductive biases. So what I'm showing on the right here is an example of different learning objectives for a code generation model. I think it's code T5. where they define objectives that are customized for the structure of code. So for example, they will mask out constituents in the syntax tree of the code instead of just arbitrary substrings of the code. And this works to improve the model a lot better. But what they're using here is they're using the fact that code does have this hierarchical structure, and that's how they're designing the objective function. Okay, all right, so again, our working assumptions in NLP pre-2019 is that in order to understand language, we first need to understand our atomic units, and we have to understand how they're composed, and then this will give us sentence meaning. And we need to model these processes separately. They exist as separate tasks in NLP. So what actually happened? Because this isn't really the case anymore. We found that self-supervised approaches, so for example, just language modeling on arbitrary text, mean that we don't necessarily need to learn word embeddings independently of sentence meaning. And in fact, so this is going back to the linear probing that I was talking about earlier, we can actually recover a lot of these structural features like parse trees, for example, that we were explicitly modeling before just from these representations that we learned from self-supervised learning. So this is pretty neat. So the next question is, well, okay, what if we could do more than one task with a language model? So there's a bunch of tasks we've all studied. Now we have one model that seems to be able to do a lot of different things. How can we unify that model's interface to do a bunch of different tasks? So I want to talk a little bit about a work that was very much ahead of its time in 2008, which is a general deep architecture for NLP. So this was a model that first takes words, turns it into embeddings, provides positional embeddings, uses convolution-based context window processing to support variable length input sequences, and has a multi-layer prediction for different classification tasks. And they used classification tasks like part of speech tagging, semantic role labeling, and a bunch of other like standard NLP tasks. You just train this model end to end with backpropagation, and then you have a model. And we also have some unlabeled training data that we can use as a language modeling objective to get this model to work. And this is very cool because this is very similar to like what we were doing with like BERT-based models. But I think one of the reasons this has never really took off is the compute that we had wasn't sufficient enough to support this kind of model, and we didn't like take advantage yet of like web scraping. And actually, I mean, I don't know how much the internet has grown since 2008, but I'm assuming quite a bit. Okay, so all right, so we want these multitask models, and in 2017, we got a model or an architecture that really works very well for this, and that is the transformer model. So here's an example of like one of the transformer units, and here's a picture of a transformer that exploded in Queens that I saw from my roof in 2018. Okay. All right, so the attention model, is nice because it makes training easier. We have fewer structural inductive biases. It likes a lot of data, which we have now. And so we can train at scale. And now transformers are the architecture for NLP, and multitask is what we expect out of our models. There's also this bet ongoing of whether transformers will be the last like NLP architecture. Oh yeah. Right, okay, exactly. So the idea would be you have a model that you've trained on a bunch of data, and you, like early models like BERT, you might take a representation from inside that model and then train a small model to like do sentiment classification on the sentence, for example. And the idea is like now you have some representation of the sentence that you can do any NLP task with without really training. You don't need that much like labeled training data. You can just sort of generalize to a bunch of different tasks. Yeah, so you can get a lot from a bunch of unlabeled data and then a small amount of like labeled data for a bunch of different NLP tasks. But typically, the way that we have to train these models or evaluate and run inference on these models is either next token prediction or through like masking objectives or training like a classifier head on top of an internal representation. So how can we make these multitask capabilities more accessible? So of course, I'm sure everybody here has heard of like few-shot prompting or in-context learning, where you provide examples of a target task. The generalization question being, can our model complete a target task successfully given no or only a few examples? now we start to have this question creep in of, well, can we know if the model didn't actually have any training examples with this task in it? So you can see here, this graph is showing that with more in-context examples, you perform better at some task. This is like just a general language understanding benchmark. And one thing we start to see as well is, OK, so we trained our model on this general language modeling objective, and we can do this few-shot learning, and it works pretty well. But how much of the training data actually included multiple examples that we're in the same format that we're providing when we're doing few-shot learning? So can we perform better if we augment our training data by including examples of few-shot learning? So basically aligning the model at training time to expect inputs more like what we're going to give it at test time with multiple examples. And this performs better, which is good. Another way we can do this, which is even better than few-shot prompting, is just through some conversational natural language interface, and that's where we get RLHF. We collect some data from human annotators. We train a reward model that reflects human judgments of the responses to their instructions, and then we use RL to fine-tune a model on that, and we can get some chat model out of it. Yes?
Mapping a question and examples to an answer, or just a question to an answer?
I guess I mean, I don't know. That's a good question. I think my own definition would be that it doesn't necessarily matter. I don't know. Yeah, because like you could do zero-shot prompting, which is essentially just asking a question, right? And that's also exhibiting like trying to do the task. Yeah. OK. All right. So to summarize this, we have trained models on as much data as we can, scrape from the web, and then fine-tune them on data that more closely looks like what they will be exposed to at inference time. And then what we expect is good performance from these models across different domains for different kinds of data, across different reasoning tasks in an accessible chat format. And I think one of the reasons why these models work so well and generalize so well is that we're making them in domain. So we're augmenting our training data, we're adapting our losses to have more interesting inductive structural biases, and that's making the models look closer, like expect things that are closer to what they're going to get at inference time. I'm not sure if I'm going to do. Yeah, I might just very briefly go over the next slide, which is that people still talk about what it means to do generalization, especially in a task-based context. So you have some training data. Can you train on that data and expect something else? Like if you train on a set of easy examples for some math problem, can you generalize to like more complex problems? What does it mean for a property to be emergent? I'm going to talk about this later. And I think there's this question of what does it mean to evaluate generalization when we actually don't know what's in our training data? And is the ability to generalize something that's dependent on the model training data? And if so, then like how can we say what a model is able to generalize to? There's an interesting workshop at EMNLP last year called GenBench that goes into a lot of this, and the keynotes there talk a lot about like implications of this on evaluation. But I want to move on and talk about something that on the surface probably has nothing to do with LLMs. Before I do this, I want to ask if there's any like burning questions. Yes?
You said one of the advances of generalization has come from changing the loss function. What are some of the different loss functions that people have been finding?
So I was mostly referring to stuff like where is that? Oh, wait, sorry. Like this, where you have different objectives that are constructed and designed with respect to like what you think the target domain looks like. So in this case, the masking objective is designed around the like hierarchical structure of like a syntax tree in code. Yeah.
We're on this slide actually. So I guess for number 2, usually the pre-training loss has some part of this self-supervised loss, like in test time training. Is this still like I guess how widely used is this still?
Sorry, what do you mean by?
So I guess like for 2, I think usually what you do is you include a little bit of like, a little bit of the self-supervised loss you're going to fine tune with downstream in the pre-training loss itself. Or is that maybe not what you're referring to?
I think I'm referring to, okay, you have a pre-trained model and then you have some labeled data in a specialized domain and you want to fine tune on that data.
But for 2, you don't have labels, right?
Oh, for the second one here?
Sorry.
Yeah, yeah, I think what people will do is they will do like pre-training, but include a bunch of data from the target distribution. Yeah.
You had a slide where you said there was a bet on is attention all you need?
Yeah.
I have a silly question which you can feel free not to answer in any depth, but how will we know the answer to that?
I don't know. I guess when there's, I guess one way to I don't think about this question a lot myself, so maybe I'll try. I guess if we have like an architecture that's not attention that suddenly everyone's using instead, and why would they use it instead? I don't know. Maybe it's more efficient, computationally efficient or something.
I looked at the website.
Yeah.
It's specifically whether transformer-like architecture would be the top of the most benchmarks.
Okay, benchmarks. Yeah. So I guess actually we don't really know if transformer is what like ChatGPT is based off of now. I mean, it probably is, but yes.
Question about several things, especially that. So you talked a lot about evaluation and metrics, and I'm curious if the problem here is that we don't really know what we want, or just in that how do we actually run a benchmark? Like we don't. And you understand? I don't know if this is clear enough. Like, for example, this last issue you mentioned of like whether it's in the training set or not. As long as I perform well, do I care whether it's in the training set or not, or is it just if I run my benchmark, am I actually getting a good estimate of the correct performance? Like, okay, maybe we'll face it this way: is the person with defining the actual population objective, or is the problem with how do I actually measure it in my lab? In the benchmark that I'm running with finite data.
I mean, I think like. Maybe what I'll say is I think that claims should be made with respect to training data. Like, I mean, and so if we say that a model has a particular capability, maybe it does because of the training data, and maybe it doesn't. But if we want to call it an emergent capability, we need to be careful that that data is like not in the training data already.
You didn't talk about emergent.
I very, very briefly did, but I'm not going to say more about it. No. Yeah. Okay, I'm not. I have more interesting things to talk about. Okay. Okay, maybe one last quick question.
You said something about not adding any more to explicitly represent structure, such as I think you were talking about.
Yeah.
The word embedding, all these things being done automatically. One of the things I was wondering is, in terms of like, let's say, like parse tree, is that something that's been verified that somehow internally some type of parse tree is being?
Yeah. I mean, so there's certainly a lot of work that. I mean, I don't know what the exact numbers are, and maybe the other NLP people in the room can like confirm or deny this, but I think there's a lot of work that shows that you can pretty reliably reconstruct parse trees just given the like internal representations of like a BERT model. So the assumption there is that if you can do that at scale, then those features are being encoded and learned in the model. Yeah. Okay, I would like to move on. To talk about how this kind of generalization is different from what we do when we use language. Okay, so, all right. Anyone want to answer the question of what language is? If not, that's okay. Because I'll tell you what I think, but I'm curious what other people think before I tell you what I think. Yes. Okay, cool. Yeah. Sorry? Oh, I'm just curious what people think the answer to this question is. Sorry. A technology that allows people to communicate. Okay. Yes.
I would just add like driven by the sociological needs of like certain communities and that people interact in.
Yeah. Cool. Okay. Cool. Mapping between. Okay. Mapping between strings of meaning. Okay. Cool. All right. So I'm gonna like tell like a little bit of a story of how I think about this, but this is not just like, I mean, this is just how I think about it. So I'm curious what other people think. Okay. So communicative acts. Under what conditions are we producing communicative utterances? I think that if we want something to change in the world, this is when we would produce, this is one necessary condition for producing a communicative act, because if we didn't want anything to change, why would we take any actions at all? Yeah, definitely. I mean, it depends on what you're, like the context, like I don't know why you would, but like it depends on the context in which it's used, is going to be like the reason, what we want to change in the world. So I can't say for stories in general why people tell stories exactly, but sorry?
Storytelling, tell a child a story.
Yeah, I mean, yeah, definitely. I mean, you might want to teach them a lesson about the world, or entertain them, or something like that. There's like a bunch of reasons why we would.
What is something, give me as an example of not wanting to change something?
Eating? What about it?
Well, no. So I'm saying that's this is a necessary condition. But we also. So. All right. So we also need to. Okay. Another necessary condition is that we require assistance from another language user to make that change. Because if we could make the change on our own, then why would we recruit someone else to do something? And we also do this when we know that those that we are recruiting to help us have a different model of the world than us. Because if they knew exactly what we were going to say or what we needed them to assist us with, why would we need to tell them anything at all? Okay, and one of the ways that this has been looked at is as a language game. Yeah.
When I'm talking to myself, isn't that language?
This is a very good point. I think it's a really, I like these like exceptions to this. I think there's one argument that if you're writing something down like as a note to yourself later, you're just talking to like the future version of yourself. But I think people also just like, saying things and like practicing language too.
Because you're changing yourself. You're not, yeah, it's an action that helps you solidify thought.
Yeah.
And sometimes you just do it, when someone steps on your foot.
Oh yeah, well I have an example of that. No, that's actually so I actually have that as an example. That is a communicative act. So you have a speaker with some intent, and this intent can be like anything you want at all. For example, if someone steps on your foot and you say ouch, like that's calling attention to the fact that they're stepping on your foot and they should probably stop, right?
Yeah, but I would say it even if I just stepped on my own foot and I was by myself.
Yeah.
I mean, here you're really focusing on the. I mean, if I say ouch, just because you already fell off my foot, you already went away. I'm saying ouch too much, which is without you stepping on my foot. Right?
Yeah.
I mean, I'm just trying to understand where that fits with the communication, or like having market conversation about this.
Well, maybe you're pointing out to him that I was rude for stepping out on your foot. Okay. Yeah, no. I'm just I okay. You have different goals, so you. Yeah, but if you're just chit-chatting with someone, maybe this is your goal is want to make a friend or something. Maybe you have some long-term goal of like proposing a new type of government, and you want that to exist for like the next millennium in your country or nation or whatever. So you write some treatise. But this is like super broad. I'm not saying that like there's like a well-defined space of intents. This is just maybe you can think of it as like goal states or distribution of goal states. And then I would propose that language meaning is the intent that motivates this communicative act. And then what the recipient does is recover this intent to the best of their ability, and then they can just decide what they want to do with it. Like if they're being uncooperative, maybe they want to do the opposite of what you ask them to do. Okay, so how do we actually get from intent to form? Form here is like words in their order, and prosody and timing and gesture. Now, another thing that I think falls under this definition of language is the form of this communicative act should not be perfectly predictable by the intended audience, because if it were, then why would we produce it? Some of the features, therefore, must be unpredictable, or at the very least, as the speaker, I should believe that you have uncertainty over what I'm going to say, and this is where we communicate. At the same time, some of the features need to be predictable, because otherwise there's nowhere to find meaning in. It's just basically noise to the listener. Yeah. Yeah, exactly. So there's this like systematic predictability in language, and we're scaffolding our communication on these conventions and regularities, like syntax and prosody and like the shared world that we can refer to. And a lot of the time, these systematicities allow for robustness against noise. So for example, like noun classes or genders in languages with noun genders is a form of like robustness to noise, and some kind of like a checksum. This structure is important because this is what we break in order to communicate. And we communicate by violating these expectations that we believe the audience is placing on us with respect to these conventions and regularities. So this is kind of related to if people have seen work from like Paul Grice on the cooperative principle, where linguistic contributions are those that are required at the stage at which it occurs by the accepted purpose or direction of the talk exchange in which you're engaged. With the conventions here proposed being that your contributions are informative, are truthful, relevant, and clear to your listener. And that if you flout or basically break any of these conventions, now we are communicating something new. So if I ask, are you going to the party? And you say, I have to work. On the surface form, like I have to work seems irrelevant to the question of, are you going to the party? So what I'm communicating is no to this question. Okay, so what is language? I am going to say, and I don't know if I even really agree with this, but that this is a language is the set of these conventions in the common ground between two language users or within a language community. And those conventions actually also include how we break those conventions in order to communicate. So it's multi-layered. We scaffold our communication on top of these conventions. As a speaker, I believe that my listener will try to find meaning in what I'm saying and the unpredictable elements of what I'm saying. And the listener will believe that the speaker is only deviating from our norms and conventions a little bit. Another really key thing to language is that these conventions are constantly changing over time. As we break these conventions, new meaning is assigned to their exceptions. So I use this word common ground, and this is a key word in and phrase in like any interaction, especially language-based interactions. So common ground is information that is known by or salient to both participants or all participants in an interaction, such that each of the participants is also aware that the other knows that information. So it's not just the intersection of things you know, but also things that you know that everyone else knows, and vice versa. So what can be in the common ground? Again, like intent, this can be like very broad. So it could be the situated context, like the physical environment. So I could refer to like that TV over there, and you know what I'm referring to. Different facts, like common sense, trivia, personal information, you know, things like that. Shared experiences I've had with my interlocutor, either in the past or things that we're going to do or things that are going on right now. Beliefs and desires and goals that we have. So if we're in a cooperative interaction, then maybe our shared goal is in the common ground. And then I think one very key thing here too is also the fact that the other person is human and trying to find meaning in the language that we're using. And this really is an essential part of being able to understand each other, is that the other person is doing this reasoning about the communicative acts that we produce. Yes. Yeah. Yeah, that's a good point. Yeah, I mean, I guess, well, yeah, that's a good point. I haven't thought about human and other animal communication that much, actually, but yeah, I don't know. That's a good point. Yeah. Yes, yeah, absolutely.
So Chomsky has this book that says that only humans can have language because he takes the definition of language to be some kind of universal communication in which you can express any internal state that you have, and animals don't have that. So like maybe a different audience would just call this communication and then everything else would work instead of language.
So I'm sort of being a little bit, I don't know, the reason I said I don't know if I agree with this is that typically language only really refers to stuff like syntax and morphology and other things like that, and less when it comes to like gesture or other like social conventions. So maybe I would modify this by saying like a communicative protocol or something like that, but yeah. Okay. Okay, and we are able to change the common ground, including the conventions that we're building our that we're using to communicate. So language use is productive, meaning in my definition here, we can change language in the interactional context in which it's necessarily embedded. The conventions that we use to communicate actually constrain the scope of intents that we can carry out. And I actually disagree that we can use language to express any internal thought, because if we have intents that are so esoteric that we can't use existing conventions to communicate them, then we can't achieve those intents. And this is partially why the conventions that we propose or reject or choose to take up the processes of proposing, rejecting, and uptake of conventions are usually, or not usually, but are often extremely political decisions. Like, what is the definition of a particular word? How am I going to, what are the abstractions that I'm going to form that other people will use to communicate with each other? Okay, I don't know if I might just very briefly, so there's a lot of really interesting things people do with language. You can communicate. This is not even like a linguistic task, but a communication task for teaching from demonstration or teaching via examples. So what is the minimum set of examples, and what are the examples that you give for this teaching task? We know that languages converge to extrema in like tight-knit groups. So like if you've ever experienced being at home with your family and you realize just how like strange your communication is you've been constantly communicating with each other and evolving your language over time. But you also have aspects of language contact where two different very different language groups come into contact but still want to communicate with each other. So there's these interesting processes of how languages develop from this kind of contact. And then another random point is who's changing language the most is usually younger people, usually teenagers, and especially young women. Kids are very innovative in the language that they use, and this drives a lot of like social language change that we see. Okay, language is not just a one-shot thing. We are communicating in turns. And this is sort of a special case of like a multi-agent system where our communication protocol is not fixed. We're actually constantly changing it as we're using it. This actually allows us to perform some meta-level reasoning about how us breaking expectations might change language in the future. One example of this is like convention formation in multi-turn interactions. So who here has not seen this thing before and wants to tell me what it looks like? No one? Yes. A chicken, okay. Did anyone see anything else?
Person falling over.
A person falling over. Okay, great. Okay, so a person dancing. Yes, awesome. I don't know if I can see the chicken, but I can see the other two. Yeah, I'll have to look at it again. But okay, so first of all, I just gave you some novel stimulus, and you were able to like come up with something that most people, I think, can anyone else see the chicken? Okay, good. So you can see other people understand what you're saying, right? And so this is something you've never seen before. You can name it, and other people can understand you. I think that's pretty cool. So one example of convention formation, this is coming from an older task that's called an iterated reference game, where you have one person trying to identify a number of these abstract figures by referring to them. And over 6 rounds of this task, you can see they go from calling this thing, this next one looks like a person who's ice skating, except they're sticking 2 arms out in front, to, at the very end, ice skater. So this set of people, this dyad, decided to call this the ice skater. In this very first utterance, basically they've cemented, okay, it looks kind of like an ice skater, and here, now this is the reference that they're using to refer to it. So now we've converged on a reference specifically for this figure that nobody else here thought looked like an ice skater, at least those who answered my question. Okay, so how do we actually coordinate with each other in these multi-turn interactions? There's a number of different theories on what this coordination looks like. So for example, this theory from like Pickering and Garrod is on alignment in conversation, where instead of just basically trying to recover a single message all the way from the signal through all of this like linguistic hierarchy, instead what we're doing through interaction is we are aligning our representations of like the lexicon our interlocutor is using such that we have even more of a common ground, and this facilitates conversation better. And one of the things I think is really interesting about this is because it's a coordination problem that's happening like in real time, I think this makes it very difficult to like understand interactions that we're not actually part of. And I think another reason is that when we're not actually part of an interaction, we have less of a stake in it and less of an incentive to actually do this coordination and build the common ground with the interlocutor if we're not actually there. Another model for this that you may have seen before is the rational speech acts model. Just a very brief description. The proposal is that we index into our model of our interlocutor in order to choose the utterance that is most likely for our listener to interpret as our original intention. So I'm a speaker, I have some intent, I want my listener to recover that intent. I can't just do some forward inference to say, okay, intent, utterance. I instead want to say, okay, if my listener interpreted this utterance, what would they think I was trying to convey? And then which is the utterance that would maximize the probability that they recover that intent. Okay, so this is a little unrelated, but I think it's kind of an interesting perspective that I like to think about a lot, is all of these interesting features of language itself as some intelligent entity. I don't actually like believe this, but I think it's really interesting to think about language as this really interesting system. So language is an entity apart from any individual person. It's this set of conventions that lives like on top of the human social network. It is animate, it's constantly changing as it's being used. It's coercive in that it constrains and frees us in the intents that we can achieve. It's self-aware. We use it to negotiate its use. We're like constantly talking about what words mean. I think it's a fun exercise to like listen to a conversation and think and like identify all the points where people start either explicitly or implicitly arguing about what words mean. It built the world around us. So one thing I also like to do is think about, okay, I'm here right now. What are all the conversations that happened to get me where I am right now, or to make this room like the way it is? I think it just, that sort of creative exercise really shows like the vastness of language. And language is immortal. You know, we've had languages for thousands and thousands of years. But individual languages are not. Languages, unfortunately, especially in the last like century or so, a lot of languages are dying out, which is really sad, especially because there's just so many different languages that really exhibit like the full range of people's cognition. I think it's just super, super cool. But yeah, this is not great. Okay, last short thing is on language acquisition. So how do we actually learn language as babies? The earliest oh yes, sorry.
Language, not English.
Yeah.
Or
yeah.
math speak.
Right.
Like this other like conglomeration of language which includes Ethernet.
Which includes what?
Ethernet.
So I actually don't think things like these protocols are really language because they don't dynamically change with their use. Sorry?
LZ, like adaptive compression scheme.
I don't know. I don't know, actually, maybe. I'm not familiar with this, yeah.
You're referring to that collective?
Yeah, I'm referring to like the general phenomenon of language, and then a particular language, like an instance of a language, is that set of conventions that's like in the common ground of a language community. And language communities can die out.
Yeah.
It's a bit facetious, I think. It was just pointing at interesting features of language from the perspective of what if we thought of it as an intelligent being. So I don't think I mean it very literally. Okay. Very briefly on this, and then I want to talk about LLMs again. Okay, so the earliest communicative acts that we produce are pointing gestures. This asks our audience, usually our parents or guardians, to share attention with us. That is the sort of intent behind our pointing. The earliest structured abstractions that are non-linguistic, these happen to be things like scripts and routines that we are aware happen in regular life, like, for example, how the dinner table is usually set. Our earliest language-based communicative acts are those that carry out complete intentions, not necessarily individual words. So I don't know, going back to the dog thing, right? If you have a dog and you can say, do you want to go on a walk? And that itself is like a single communicative act. And you will know that you can't even necessarily say walk, or you can't say that phrase without the dog kind of going crazy. Okay. So when an adult speaks, children try to find that adult's underlying intention. They search for meaning in that communicative act. The acquisition of the words comes later by having these subparts repeated across multiple contexts. And children will test out hypotheses about language use by observing an adult's response to their testing of these hypotheses. There's also this question of how do children learn to produce new constructions. And one of the hypotheses is that they also learn these structural abstractions from observation and distributed across different contexts. Okay, generalization in natural language. I will say one thing that I think is the ability to use language is not just the ability to model like token by token or something like that, but it's the ability to actually learn language and to participate in language-based interactions and drive forth its dynamics. When we use language, we are generalizing to new goals and intents, including goals about language change, new interlocutors with uncertainty over what the common ground is that we share, new situational contexts, new constraints on communication media. So for example, that task that I briefly showed with teaching by examples in the rectangles and stuff is a new communicative task you might not have ever seen before, and you're constrained by only being able to communicate little dots you can place on a board. And then constantly changing conventions as we're interacting. And this is all happening under resource constraints that we generally share and know that we share with our interlocutors. Okay, all right, now I want to talk about implications for modern language technologies that I think about when thinking about language. So these are also not really ordered. Okay. There's this interesting thing that I've been thinking about called the long tail paradox, and this was very well described by Hal Dome like a year ago, where he asks, which of the following words do you think is the most rare in English? Myriad, solipsist, anachronistic, and appricate. Anyone want to answer? Yeah, the most rare of those four. Appricate? Appricate? Or appricate? Oh, no, they have to be like word, like lexemes.
Also, like maybe appricate is like a specialized word that only doctors use. I'm saying like generally.
Okay. Yeah. So of these four, that is the rarest one. So does anyone know what this word means? Okay. Now, if I have this sentence, eating apricots and applicating himself while while on a garden wall, I think there might have been a typo there. His hands in his pockets. Does this give any more information? Do you have a better sense of what the word might mean? No. What about when I show this photo? Okay. Maybe this wasn't the best example, but it means basically to bask in the sun. And here this crow is sunning itself to get rid of parasites. Okay. Okay, but from context, you were able to narrow down what you think this word means, right? All right. So does anyone have a rarer word?
Yellow.
Yeah. What? Okay.
N-I-E-L-L-O.
Where's my mouse? N-I-E-L-L-O.
Yeah.
No. Anyone else have a word they think is rarer? Yeah.
Influent. I-N-C-R-U-E-N-T.
Oh.
Let me see. It's really hard. Is that right? Oh, no. I cannot see this.
Your first NCI.
Can you make it a little bigger?
Ah, wow. Very good. Okay, but all right. Very good. What does that mean?
I have absolutely no idea.
Okay.
It's in the Cormac McCarthy novel.
Oh, okay. Okay. Okay, so there was this question that I was talking with someone about, which is like, what's our denominator when we're evaluating these systems? Like, what are we expecting them to be able to do? So inventing long tail or edge cases for evaluation is difficult. Maybe not so difficult necessarily, but I think it has shown time and time again in NLP that, and like other machine learning tasks, that coming up with these examples from scratch is quite difficult. But I think these cases actually make up a large amount of our regular language use when we use language in its natural habitat. And this is why I think my talk is incomplete, because I often will have like a conversation with someone and be like, whoa, that was like a really interesting language thing that I haven't thought about before. And then I don't know, I should think about this more. But I can't come up with these things, without experiencing them. Yes?
So how do you distinguish between the long tail in terms of like it actually being long tail versus because of the way we collect data? Like if we're scraping data from the internet, it's not like everybody across everywhere in the world has their way of speaking on the internet, right? So I'm just trying to understand that when we're looking at this long tail, is it more to do with the generally something's long tail versus it just doesn't happen?
Yeah, generally.
But if I had collected data more broadly,
I think, I mean, I think that it's the case where it is genuinely like out of distribution. And in these cases, we're able to reason, at least best effort reason about it. Yeah. Oh, and my other point was that we can, even if we don't have a great idea of what these long tail things are like, we can attempt to understand them. We can deduce meaning, for example, like through context. And if we can't invent a test set that covers these long tail cases, how would we ever know that our model generalizes to these cases? I don't know if there's an answer to this. I mean, you could. They're common, but they don't have like a shared distribution necessarily. Like you can't characterize what it means. You can't characterize what the average like long tail example looks like because they're all very different from each other.
Like in aggregate, there's a lot of them, but like
individually, they're very out of distribution.
Well, on your words in general.
Sorry?
But they could check whether you do well in their words.
Yeah. I mean,
it's an evaluation a bit.
I guess I'm not talking just about rare words. I'm also just talking about situations, for example, like, so we had this data set that we were creating, which was attempting to like bridge gaps between between common events that would very rarely occur like one after another, like very rarely be causally related. And we wanted to invent examples that we could test our model on. And the only way we could think of doing this was like scraping examples of like common events and then like permuting their orders or something like that. But it wasn't very satisfying to us because it didn't seem like they're not like super plausible anyway. I don't know. But when we would be out on the street, I don't know, like experiencing the world, these events would happen to us and we'd be like, that would be a perfect example in our evaluation set. But it's very hard to sort of come up with a data set of thousands of these without actually experiencing them.
So I'm still confused with this contradiction. Because I'll go out the world, collect stuff, and then find them in what I collected, right? So
well, so I guess my point is, even if you were to mine examples from like the long tail in the real world, that doesn't necessarily mean that you're able to do well on the long tail like going forward, because the distribution is not the same.
Okay, that's it.
Yeah. Okay. Yeah, I wanted to no, it's totally fine. I've made too many slides. But one issue here is that because people adapt to the tools they use, we actually are probably going to see fewer and fewer instances of like stressing the limits of these models, because people want to feel like they have agency in the tools they use, so they'll constrain themselves in the language that they're using and the expectations they have of the models. So we'll actually not even be able to test these necessarily in the wild through deployment, because people won't be expecting the models can address sort of long tail things in general. Okay. All right. So another aspect of evaluation of these models are auxiliary task demands and model robustness. So as I talked about before, there's a lot of different techniques for soliciting behavior from a model. Next token prediction, few-shot prompting, instruction following. So when can we say that a model has some capability? I think this is like kind of an open question and maybe like a debate. Can we say that it has a capability when there exists some technique for which it produces the correct behavior? Or do we expect it to reliably produce the correct behavior under all reasonable techniques? So what else should we be expecting from these models? One thing I would argue is that they should be able to engage in the kind of interaction dynamics that I talked about when I was talking about language. Do they actively participate in interaction like people do? Do they generalize to new users with new goals and intents under uncertainty over their common ground? Do they adapt to a constantly changing common ground? Do they adapt to new situational contexts, new constraints on communication media? For example, could you take an LLM and get it to do that like rectangle teaching task? No, probably not right now. And I know someone who did this experiment. No, you can't. Do they actually drive forth language change? Do they propose new conventions? So this chart is looking at a couple of different language models and over time, whether their utterances are getting shorter and shorter in this reference task, which we would expect it to, because this is what we know from humans in these iterated reference games. No, they're not. They're not proposing new conventions. They're not taking up new conventions, unless we try very hard to prompt them to do so. Which I don't know. Does that mean that they have that capability? And do they ask clarifying questions like people do? Generally, no. Another form of generalization is how languages are so different from one another. Language is not just English, obviously. It's also not just text, but it's also not just speech. People use signed languages. There are touch-based languages. People use AAC devices for communication. But regardless of the medium, one of the things that's very common ground with all language users is that we use language to connect to one another. Another thing for evaluation is sort of this fallacy of optimal language use. We're very sloppy at using language. I could refer to something with a completely wrong term, and it might not matter, because you might even start using that completely wrong term too. Because if we're in a shared situational context, it doesn't matter if I'm very precise. But this is perfectly fine. Language is interactive. You can ask for a repair. You can say, what do you mean? And I can tell you. So what does it mean to like optimize language use out of context? Yeah, I'm trying to get to the end. I also think this is an interesting quote from Stuart Schreiber in this retrospective on the Turing test, which is that people are easily fooled into reading structure into chaos, meaning into nonsense. How much different is interpreting non sequitur as whimsical conversation? So what I'm wondering, like modern day, is like when we read AI generated text, are we accommodating this model by believing that's what was surprising to us in the text was actually generated from some intent, or is it generated from like true noise? Talking about system design instead of evaluation, these are some of the open questions. Is language the most appropriate interface? How can we avoid model collapse? So constraining these models' communication conventions while encouraging people to stay expressive in their language use. And then how can we inject like agency into learning to get these models to learn language efficiently and like people do? Okay, I wanted to just say thank you, and that there's even more stuff that I wanted to say, but I definitely don't have the time. So I'm curious what people think. Thank you. Yeah. Yeah.
So just so that we can maximize use of the reception, she will be there and we can speak with her there. I misspoke earlier. We don't have to leave the building at 5. It's always this room that we have to vacate at 5. And anything that involves assignment staff, we always have to be done with it by 5. So you can stay here as 5, just if you don't assignment staff. So let's thank all the speakers today again.